I am Professor Aldo Drago from Malta with experience over a number of years of activity in operational oceanography through the Physical Oceanography Research Group, XPO unit, which I established in Malta. My talk today is intended to present the Porto Online interface, which is an innovative marine data visualization tool that was developed now already more than a year ago in the Calypso South project, an Italia-Malta Interreg project which I led with the participation of Maltese and Sicilian partners. The URL address to this portal is written at the right bottom of the slide. Let me start by making a short preamble. Well, as you know, the digital area has opened new realms for ocean data delivery. As more users become dependent on reliable information deriving from multiple data sources, the non-professional users are increasing in numbers with different demands from those of professional users. Technology is leading to a step shift in the value addition chain of data to transform data into information, knowledge, and intelligence, providing sophisticated user experience online, requiring faster delivery and service elaborations on a wider range of more affordable smart mass media like iPhones, iPads, and other wireless devices. While providing more elaborated deliveries to expert users, the digital environments add a new dimension to data services by matching fast delivery to user experience, expectations, and demand. This has led to the concept of featured data services. In contrast to the traditional generic services, the featured services are usually dedicated to a category of users with specific needs, providing routine data-derived products to support their operational day-to-day activities or production lines. User categories can be from industry, such as in relation to the tourism sector, for example, to provide higher-level information services. Compared to the static delivery of pre-prepared products determined at source, the featured web services use a dynamic added value production, composed directly by the online user who can customize the service to fit a specific need or query. Four essential ingredients of featured services are therefore: 1. GIS-like web tools for geographic rendering and mapping. 2. User-specified dynamic content delivery. 3. Online functionalities to elaborate data online. And 4. Real-time updating of data and information. Porto Online is indeed conceived as a featured data services as it specifically offers metocean information delivered to especially 8 harbour masters, port authorities, and operators in the shipping and maritime services in the proximity of the Maltese Islands and south of Sicily. Data for the interface comes from various sources, including both observations and numerical model data. The presentation is too short to allow me to go in detail on the backend structure of Porto Online. Just to say that the web service draws data from various data sources and types, converts them to XML or JSON to be subsequently deposited on the Porto server. On the user side, HTML files are used, and in particular, an HTML5 local storage facility allows the user to save the customized individual preferred configuration from one session to the next without the use of cookies. Bootstrap is used to make the interface responsive to the user device and enable it to be mobile friendly. The interface uses Google Maps JavaScript to enable the display of georeferenced data as an image over various types of maps, such as satellite images, terrain, or street maps. Uses Ajax so that the interface can start being rendered while data is being called from the server, and uses HighCharts for chart display. It is deployed as a progressive web app, allowing users to eventually download it onto their mobile device for easy access. I now take you briefly through the interface, showing its very slim, versatile, and user-friendly concept, probably the first of its kind in Absolute, facilitating the users to view the data they need, find it in one place, and easily search through without effort by means of an organized dashboard. Some basic controls are at the top of the dashboard. The data layer selection takes you to the datasets. Data layers are organized into model and observations and can be overlaid for comparison, very much like in a GIS-based system. Some layers are static, like bathymetry or climatologies, so that the user can reference operational data layers against the static ones. Several data sources of the same model fields are also available for intercomparison of different model realizations. The links on the top left side panel point to specific station data like meteo and sea level stations and give access to detailed data lists and charts. Similarly, model wave spectra can be viewed at selected stations, shown in yellow, and again, each linking to detailed animations of sea conditions. The dashboard also offers viewing and superposition of georeferenced information like ports, bunkering areas, and oil rigs, providing metadata information on any selected feature. A facility also offers viewing specific subareas in higher resolution. A data layer is, for example, here selected for model sea surface temperature, and the dialog box can be opened to follow information by moving the mouse from point to point over the data field, such as the red asterisk in this case. Further clicking on the data layer provides a time slider to view the temporal evolution of the selected data field. The same can be done by repeating the process on any selected subarea to view the higher resolution maps. Data layers are also include derived parameters like wavelength and wave model data, or vorticity, divergence, and mean and eddy kinetic energy in HF radar data. The last slides show the 4 essential ingredients of featured services. 1, GIS-like web tools for geographic rendering and mapping, allowing the overlay of vector and scalar fields from different sources. Secondly, user-specified dynamic content delivery, that is, the user is able to select and compose the dashboard that is needed, customize the data viewing individually in the form needed, and understand and with ease access and view in just a few clicks. The customized dashboard can be saved to upload again in a subsequent session. Thirdly, online functionalities to elaborate data online by using online elaboration of metrics in user-defined areas or along selected transects. These functionalities are not yet public in Port Online. And lastly, real-time updating of data and information, merging observations with model data and linking hindcasts, nowcasts, and forecasts. Thank you for listening, and I invite you to visit Port Online, only one click away to what we ambitiously define as an innovative visualization tool that can inspire future porters to follow.